let's talk about the product rule. So the history of this, I think, is that when calculus was being invented by Leibniz and Newton, Leibniz originally thought that if you take two functions and multiply them together, and then you try to take the derivative of the result, then that derivative should just be the product of the derivatives, right? So the initial guess was that if you take two functions, f times g, then their derivative would be f prime times g prime. And that doesn't work. And the reason why that doesn't work is, say that you picked maybe f equals 1 and g equals x squared. So that's just x squared, right? And say that you took its derivative. So if it were true that this were equal to the derivative of 1 times the derivative of x squared, well, the derivative of any constant is 0, we know that. And the derivative of x squared we learned from the power rule. It's just equal to 2 times x. So 0 times 2 times x just equals 0. So it can't be true that the derivative of x squared is equal to 0. Therefore, it can't be true that the derivative of f times g is equal to the derivative of f times the derivative of g. That can't be true. So what is it equal to? Let's try to find out. Okay, so if I take something like this and I want to figure out its derivative, again, at the beginning of the course like this, we have really no recourse other than to just go back to the limit. Say limit as h goes to 0. Let's take the derivative of f times g at the point x. You can notate that by using this little dash for derivative, and then x telling you taking the derivative of this function at the point x. And the definition of that, and let me put an x through this because it's bothering me, that false statement with the equal sign. So, but let's write down what the definition of this derivative is. So I have to take f times g and plug in x plus h. It's going to be f of x plus h times g of x plus h. And then I'm just subtracting f of x times g of x, all divided by h. And you hope that out of this you can get some formula that you can rewrite in terms of derivative of f, in terms of derivative of g. And it doesn't look too promising what you've got here, because you're looking for something that you can factor out, but you don't really see anything. So what I'm going to do here, I'm going to do the trick of adding the number 0. I call it the add and subtraction trick. So what I'm going to do is I'm going to take this limit. It's going to take a limit as h goes to 0, and I'm going to not alter it in any way, except what I'm going to do is subtract f of x plus h times g of x, and then I'm going to add it back. And then I'll subtract f of x times g of x, and that entire quantity you're dividing by h. So I really didn't change the value of the limit here, right? Because you've got the numerator like it was before, and then I just added the number 0. I added and subtracted this. And so that's just a device to help me re-express this limit in terms that I can understand a little better. So no funny business. But now that I've got this, I can start trying to factor things out. I can factor out f of x plus h from here, and I can factor out g of x from there. And let me do that. So continuing on, I'm going to get the limit as h goes to 0. And first I'm going to factor out that f of x plus h. That's going to be multiplied by g of x plus h minus g of x, right? That's those two terms, and I have two terms that are left. And let me combine another step into this. So the sum limit law says that a limit of a sum is the sum of the limits. So if I take this first part of the expression, which is written here, and then I look at the second part of the expression, so I'm adding to it these two terms divided by h, so I can split that limit up. So the limit h goes to 0 of this last part. And here I'm going to factor out the common term, which is g of x. And I'm going to be left with f of x plus h. Minus f of x. Everything divided by h. So you see I started with this big expression. I broke up the sum into two limits, which I'm allowed to do so long as those two limits exist. And then I just factored out the x plus f of x plus h and the g of x. So now what I want to do is, since h is going to 0, I have to ask, can I take these two limits? Well, this limit itself is a product of f of x plus h and this difference quotient. So I can rewrite this as limit. Using the product limit law, this is limit of f of x plus h as h goes to 0 times the limit as h goes to 0 of g of x plus h minus g of x over h. That's the definition of the derivative of g. That's the definition of the derivative. And now for this term, I'm getting limit as h goes to 0. So g of x does not depend on h. That's a constant. Using the constant multiple rule, I can bring that out and end up with limit as h goes to 0, f of x plus h minus f of x over h. That's nothing but the definition of the derivative of f of x. So I'm almost there. I just have to calculate that limit. So this limit will be f of x. That is to say, this limit, I'll be able to calculate it by plugging in h equals 0, so long as it's true that function f is continuous. That's the definition of continuity, that when you take the limit, it's equal to the point that you're limiting to. And generally speaking, I don't know that, but if I assume that f is differentiable, then I know that it has to be continuous, because we've seen that in a previous video. So using that fact, I can rewrite this as f of x times g prime of x plus, and I'll write this as f prime of x times g of x. I just switched the order there a little bit. And what we started off with was the definition of f times g and take the derivative. And I'll put in the variables here. You could say f of x times g of x and take the derivative, or you could say f times g and plug in x. That they mean the same thing. So I've shown, just using the limit laws, this nice formula. This is called the product rule. It tells you how to take the derivative of a product. Let me do a quick example to put that into perspective, using some things that we already know how to differentiate. So what if I gave you a function like x squared times e to the x and asked you, please take the derivative of that? And since I asked nicely, you want to do it. And so what you do is you say, well, just following in the formula, f times g prime. So here's my f, x squared. Here's my g, It's e to the x. So f is x squared times derivative of e to the x. Derivative of e to the x is e to the x. We've seen that. And then I add to it derivative of f, which is just 2x, times g of x, which is e to the x. So now that you know the product rule, this opens up lots more derivatives that you can calculate. Any two functions, you know that they're differentiable, you can find the derivative of their product, and you've got a nice formula for it.